about what is similar and what is different between the circle, the ellipse, and the hyperbola. So what do you see that's similar? What's the same? Okay, you have y minus k and you have x minus h, except the x minus h is not squared. It almost looks like it's supposed to be, but somebody just left that off. Well, they left it off on purpose because that's what makes a parabola. Okay? When the x is not squared, I'm going to teach you the hardest part first. When the x is not squared, the parabola opens left or right. Okay? When the x is not squared, the parabola opens left or right. So let's connect something that's common sense. We know x values go left and right. So on your parabola, when you look at that equation, if it's already in standard form, and the x is not squared, the parabola is going to go left or right. If the a is positive, then the parabola is going to go to the right. Common sense. Positive x's go to the right. If the a value is negative, then the parabola will go to the left. Okay? Now, out of all four conic sections, the parabola is the only graph that doesn't have a center. But it has something that's very similar to a center, not really graphically, but how we actually find that center. Okay? A parabola is not going to have a center, it's going to have a vertex. And I've labeled you a parabola up above there. So your vertex is going to be your HK. While all the other graphs, their center is going to be HK. Okay? So a center is to a circle as a vertex is to a parabola. A center is to a circle as a vertex is to a parabola. So do y'all think we're going to change the sign of H and K when we pull those values out of the parentheses? Yes, we're going to do that for all four conic sections. That's a similarity among all four graphs. All right, also real quick, we're going to talk about that point's the vertex. You're going to learn a new vocabulary word today. There's a point inside every parabola, and that point is called the focus. And we are going to have to talk about the focus. We didn't talk about the focus when we did ellipses, but we have to talk about the focus. That's this specific point. Okay? So that point itself is called the focus. The focus is going to be P units. And I did not draw this in, but you draw it in. The focus is going to be P units from the vertex. So we're going to have to calculate the P value, and it's going to tell us how many units to go from the focus to the vertex, or from the vertex to the focus. That'll be that little segment from the vertex point to the focus point. That's going to be the P value. All right? Then there is an imaginary line. That's an imaginary line also. There's another imaginary line that goes through the focus, and it is called the lattice, L-A-T-U-S. It is called the lattice. The lattice tells us how wide the parabola is going to be, or how narrow the parabola is going to be. So, for instance, if the lattice was 10 units long, the focus is going to be the midpoint of the lattice. So if the lattice is 10 units long, then I'm going to have to go 5 units up and 5 units down. My parabola is not drawn very perfect there. Okay? But the focus point will be the midpoint of your lattice. And we'll find out how long the lattice is, and I'll show you some really good examples. And that'll tell us how wide it is. So when we graph a parabola, we're going to graph the vertex. Then we're going to go so many units to the focus. Then we're going to figure out how long the lattice is. And if the lattice is 6, then we're going to go up 3 and down 3, because the focus point is going to be the midpoint of our lattice. And then we're actually just going to sketch our parabola in using, I'll make these points yellow. Okay, so we'll have the vertex, and then we'll have where we figured out how long the lattice was, and we went so many units to one point, so many units to the other point, and then we'll actually sketch our parabola through those 3 yellow points that I've graphed. Okay? So when the x is not squared, the parabola either goes right or left. When the x is not squared, the parabola either goes right or left. In the next box on your notes, okay, these are the equations where the y is not squared. So you have x minus h squared equals a times y minus k, and then you have x minus h squared equals negative a times y minus k not squared. So when the y is not squared, then the parabola either goes up or down. If the a value is positive, the parabola goes up, and if the a value is negative, the parabola goes down. Okay? And again, we'll graph the vertex. We'll graph the vertex, and then we'll go up so many units to the focus. And then we'll figure out how long the lattice is. We'll say the lattice is 10. So we're going to go 1, 2, 3, 4, 5 to the left. 1, 2, 3, 4, 5 to the right. And then we'll sketch in that parabola. If the parabola goes down, then the focus is not going to go up. The focus is going to go down. So your parabola will be opening down and so forth. Another thing that I want you to look at before we get into some examples is I want you to look at what's written first in your standard form. So take a look at these two equations. These are really the same equation. I've just broken them up to when a is positive and a is negative. But if you'll notice, the x minus h squared is solved for. So you're solving for x. X is on the left. X is on the left of these two equations because x is what is squared. You go back to the reference box to the left of that one. What is on the left here? The y's. The y's are on the left because that is what is squared. The y's on the left because that is what is squared. Okay? Can y'all have anything right now that's in your brain before we actually look at some specific examples?
So do we have to distribute the negative a before we graph it and stuff?
No, that little negative a will be out there because it's going to tell you, it's going to help you find your p-value, how many units to your p, and it's also going to tell you that a value is actually going to tell you how long the lattice is. So the a value is involved in finding how many units, how many p units there are, and then how long the lattice is. So that a does all of that. The a tells us direction, it tells us how many units to the focus, and it tells us how long the lattice is. So that a has to be outside there because it's extremely important. Unless it's a 1. If a is 1, then they probably won't write the 1. But that a tells us all kinds of things about our parabola. Okay? All right, so if you'll flip that note page that you have in your packet, if you'll just flip it over, we're going to look at a few examples together, and then the rest of the block today you are working on homework. So you actually ought to get a pretty good amount of time with homework today. All right, so let's start off with some examples that are already in standard form. And I know you don't have graph paper here, but I think that you'll be fine without graph paper. So this example to me looks very simplistic, and it looks very simplistic because there are no parentheses. So remember, there doesn't have to be parentheses. When there's no parentheses with your y and no parentheses with your x, that just means h and k are both what value? 0. So remember, a parabola doesn't have a center, but it has something kind of like a center. It has a vertex. So we know that our vertex is 0, 0. So there are no parentheses at all here. Parentheses affect your center or your vertex depending on what conic section that you are graphing. Okay? Now, we need to know this little formula. We need to know that 4 times p is equal to a. So, however you do things that are really important in your notes, I like to do boxes around things that are really, really important. There is a relationship between your a value and your p value. And that relationship is all in the formula. 4 times p is always equal to a. 4 times P is always equal to A. What's the A value in this equation? The A value is 4. The A value will be on the right-hand side. This equation is already in standard form. So the A value is 4. So we're going to write 4P is equal to 4. If the A value were 2, we would write 4P is equal to 2. If the A value is negative 8, we would write 4P is equal to negative 8. So 4P is the formula, okay? 4P is always equal to your A value. Now you have a little equation that you can solve for P. So you divide both sides by 4, and you find out that your P value is 1. That's extremely important. That means that between the vertex and the focus, there's just 1 point, 1 unit, excuse me. Between the vertex and the focus, there's just 1 unit. All right, so we need to know the P value, and we use the equation 4P equals 8, or the formula 4P equals 8 to find the P value. We also need to know how long the lattice is, okay? The lattice has another little formula. It's fairly easy. The lattice is the absolute value of A. The length of the lattice is the absolute value of A. Okay? And the reason we have to do absolute value is because the lattice is a segment, and segments always have a length that is positive, and sometimes our A can be negative, and that's why they're taking the absolute value there. So most of y'all will just look up at the problem. Here's our notes, but we're just going to do absolute value of 4, because A is 4, and that would just be 4. Okay? So these are the main things that you have to know to graph your parabola. You got to know the vertex. Got to know the vertex. You got to know the P value, and you have to know how long the lattice is. Got to know the vertex, got to know the P value, got to know how long the lattice is, and the fourth thing that you have to know is you got to know whether your parabola is going up or down or left or right. So let's look at what's not squared. What's not squared? The x is not squared, so since the x is not squared, the parabola will either go left or right, like the x that's not squared. And since A is positive, the parabola is going to go to the right. So there's really 4 things. So somehow in your notes, these are your notes, whatever makes sense to you, you got to know the vertex, the P value, how long the lattice is, and which direction your parabola is going to go in. Vertex, P value, lattice, how long the lattice is, and what direction your parabola is going to go in. Okay, any questions so far? All right, so let's sketch one out. So draw yourself a y-axis and an x-axis. Y'all can use graph paper later if you want to when you start your homework. I'll just let that be a choice for you. Sometimes I don't like my graphs being on a completely separate sheet of paper. I like for the graph to be right beside my work, so sometimes I just sketch these out. Alright, so you're going to start by graphing your vertex. It's at 0, 0. Then you're going to travel P units in the direction that your parabola is going to go. Then you're going to travel P units in the direction that your parabola is going to go. So that means we're going to travel P units to the right. And our P value is 1. So I travel 1 unit to the right. So the first point that I put in was my vertex. The second point is called the focus, F-O-C-U-S, just like you're focusing on something. Now I've got to draw in the lattice. So it's the vertex, the focus, and then the lattice. How long is the lattice? It's 4. So the focus is the midpoint of the lattice. The lattice is just a little imaginary segment that tells you how wide your parabola is going to be. So if the lattice is 4, then you're going to go from the focus, that's the point 1, 0. You're going to go up how many? 2 and down 2. That's going to give us a perfect shaped parabola, so it's even on both sides because parabolas are symmetric. And then we're going to draw in our parabola. We'll draw it in these 3 outer points. So that little point that's on the inside that we're calling the focus, it's still there, okay? If you want to draw in the lattice, it's okay for you to draw in the lattice. You just need to know it's not part of the parabola. So I could draw in the lattice, and I'll highlight it right there. If you want to draw in the lattice, I don't care. Just so you know that the parabola is technically that green graph. Okay? It's a lot to remember at first, but once we go through some of these, the more you practice, the better you're going to get at it. All right, so let's do another. Let's do one that's going to open up or down. So let's do another one in standard form, and then we'll look at. Everybody got example 1? All right, so example 2. Let's look at another one that's in standard form, but has a negative a. So in example 2, I have y squared is equal to negative 12x. Y squared is equal to negative 12x. I want to know this is a parabola when everything's jumbled up on my test because the x is not squared, but the y is. So there's no parentheses. That means the vertex is at 0, 0. We're going to use our equation 4p is equal to a and find our p-value. So that means that 4p is equal to negative 12, and p would be equal to negative 3. Now when your p-value is negative, that means you're either going to go to the left or you're going to go down based on which direction your parabola is going to go in. So if your p-value is negative, that either means you're going to travel to the left 3 units or you're going to travel down 3 units, and we'll figure that out in a second. All right, how long is the lattice? You probably can just do that in your head. 12 units. So we got our vertex, we got our p-value, our lattice is 12. And the fourth thing that we need to know is what direction is this parabola going to go in. X is not squared, so your choice is left or right. A is negative, so this one's going to go to the left. Vertex, p-value, length of the lattice, bless you, and the direction of your parabola. Any questions about those 4 things? So you're going to do your graph. So when I go ahead and do my y-axis, I know I'm going to have a lattice of 12. So I went ahead and went up 6 and down 6. My p-value is 3. This is a little bit easier to do if your vertex is at the origin. It won't be that hard to do. It won't be as easy if your vertex is not at the origin. Then our p-value is 3 to the left, so I'm going to go 3 to the left, 3 to the right. That'll be a little bit harder to do when your center's not, or when your vertex is not at the origin. So we're going to graph our vertex, 0, 0. We're going to look at our p-value and the direction of our parabola. So our p-value is negative 3. That's because the parabola is going to the left. So you're going to travel p units to the left and graph your focus point. P units to the left and graph your focus. Through your focus is your lattice. And since your lattice is 12 units long, half of 12 is 6. So you're going to have to go up 6 and down 6. And then you'll sketch your parabola through those 3 outer points. So the bigger the lattice is, the wider the parabola will be, no matter what direction it's going in, up, down, left, or right. Let's look at one that's not in standard form. It's just almost in standard form. Any questions about example 2? All right, example Example 3, not in standard form, but really, 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 really close. So when you're looking at number 3, you're going to go, hey, this has to be a parabola because the x is squared and the y is not. And so in parabolas, we solve for the variable that is squared, okay? So in parabolas, we solve for the variable that's squared, so that means that x squared needs to stay on the left-hand side, and that's what tells us the negative 6y needs to move over. So then we have x squared is equal to 6y. I'm not having to complete the square. Let's talk about completing the square. With the parabola, you would only have to complete the square once if you even had to do it once. Because we don't have an x squared and a y squared. You would only complete the square with a variable that is squared. You would only have to complete the square, not all the time, but when you do have to complete the square, you would only have to do it with a variable that is squared. And we'll look at that in just a second. So believe it or not, x squared equals 6y is in standard form. So you should be able to tell me what the vertex is. 0, 0. You're going to do your little equation. 4p is equal to a. So 4p is equal to 6. And this is going to feel weird because 4 will not divide into 6, but we can get decimals. I don't know why we forget that we can get decimals or fractions. But let's do a decimal here because we're graphing. So what's 6 divided by 4? 1.5 units. So P is 1.5 units from the vertex. How long is the lattice? 6 units. And which direction will this parabola be going in? Up. How'd she answer that so quick? Okay, because y is not squared. Everybody can think of that differently. The y is not squared because the what's not squared tells you whether you're going up or down, left or right. So the y is not squared, so you're going up or down, and the a is positive, so you're going up. All right, so let's sketch this one in. Now, if the parabola is going up, then the lattice is going to go left or right, left and right. So I'm going to go, the lattice is 6, so I'm going to go up 3 and down 3. Graph your vertex. And again, your P units will be in the same direction as your parabola. So since the parabola is going up, the focus is always inside of the parabola. So you'll go up 1.5 units. It's going to put you at this half mark. Then your lattice is going to go through the focus. So this time the lattice is going to be a horizontal segment since the parabola is opening up. So you'll go 3 units to the left, 3 units to the right. That'll give you a lattice of 6 total units. And then you'll sketch in your parabola. Another thing that I want you to notice about the squared term is I want you to look, I'm going to page back and look at the 3 examples, and I want you to look to see what the coefficient of the squared term is. I'm going to ask you to look for the coefficient of the squared term when the equation is in standard form. So what's the coefficient of the squared term in example 3? 1. What's the coefficient of the squared term in example 2? 1. What's the coefficient of the squared term in example 1? 1. What's the coefficient of the squared term in these just standard forms? Understood ones, even though they're right here. So if an equation is in standard form, that coefficient has to be a 1. Is that not true for all 4 conic sections? When you get in standard form, you can't have anything being multiplied times your x squared or your y squared. So in example 4, I'm going to show you a problem that starts off where there's something being multiplied times your squared term. So in example 4, I have that 8y squared plus 4x equals 0. So right away, my mind is saying I can't have that 8 there. Then I also am looking for which variable is squared. Which variable is squared? the y squared. So whatever is squared is what you solve for. Let's see if y'all can put this one in standard form with that information that I just gave you. So if I want the y squared to be solved for, what's one thing that we can do? Divide. We could divide first, or we could subtract the 4x. I personally like to go ahead and get the 8y squared by itself, but you could divide first. There's nothing wrong with that. So you're going to send the positive 4x over. It's going to become a negative 4x. And then you cannot have anything being multiplied times your squared term. So you're going to divide both sides by 8. And believe it or not, your standard form for your parabola is going to be y squared is equal to, what's the coefficient of your x going to be? Negative 0.5 or negative 1/2. It doesn't matter. And then that's standard form. So from your standard form, you can tell me the vertex of your parabola. There are no parentheses. Vertex is 0, 0. You may be stuck on the p-value. The p-value is really, 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 really small. So 4p is going to be equal to negative 1/2. So the p-value is going to end up being negative 1/2 divided by 4, which is negative 1/8. Or did anybody turn that into a decimal? Negative 0.125. Those are the same thing. Still really, 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 really small. Either one of those will work. And which direction is this parabola going to go in, since the x is not squared and the a is negative? X is not squared, so your choice is left or right. A is negative, so it's going to the left. And it's going to be really, really skinny. And how long is the lattice going to be? 1/2 of a unit. Alright, so here's another good thing about not using graph paper. So if we're not using graph paper, we can space out our little unit marks really, really wide. So we can put in 1/2 and a 1/8 and all that kind of stuff. So we'll just make our dashes really big so we can kind of estimate there instead of having to scale, which I hate to scale. So you can just space out your little tick marks to make it a little bit easier to graph. So our vertex is at 0, 0. Which way are we moving negative 1/8 unit or negative 0.125? Left, right, up, or down? Left. Now 1/8, the reason 1/8 makes a little bit more sense to me, an 1/8 is 1/2 of a 1/4, and a 1/4 is 1/2 of a 1/2, and so visually, you know, that's just a tiny bit to the left. So it's almost going to look like the focus and the vertex are just attached together. We could have made the graph a little bit, the tick marks a little bit more stretched out, but that's okay. And this is going to be weird too. So if the lattice is 1/2 of a unit long, that's not very long, right? It's 1/2 of a unit long, so you'd have to go up 1/4 and down 1/4. So you're really, you know, this is not perfect science at all. So you're just going up 1/4 and down 1/4. So you got this skinny, skinny, skinny. I went up a little bit more because my points are so fat. I wanted you to see the separation there, but y'all just kind of pretend. This is not about accuracy. If you can get the information and you're off just a tiny bit on your graph, as long as I can tell that you did the calculations right, that's all we're worried about. Okay, so now you've seen left and right, up and down. You've seen a few that were not in standard form. And so what we want to look at next is we want to look at something that's not got a vertex at 0, 0, and then we'll look at one more. We'll look at two more examples. We'll look at something that doesn't have a vertex at 0, 0, but is already in standard form, and then we'll look at something that's just crazy, crazy out of standard form. Okay, so can you think of anything right now that's running through your mind about, well, I'm wondering about this. All right, so two more examples. Anybody got a question? All right, so let's look at something that's in standard form. Are we on example 5?
Yes.
All right, let's look at something that's already in standard form that doesn't have a vertex at 0, 0. So we can just get a good look at what that looks like. So we got x plus 2 squared is equal to 4 times y plus 1, not squared. So this is how quickly you learn. You can tell me right away what the vertex is. -2, -1. You maybe can even tell me the p-value without doing any work. It's 1. You probably can tell me how long the lattice is. 4. And then I lost half of you. If you need to show a little bit of work there, you can. If you understand where we're getting these values, awesome. If you need to show a little bit of work or you got a question, wherever you're at, I know we're probably in different places. What's the last question that we have to answer? Which direction is this parabola going to go? Up. Okay, so before I graph the parabola, is there anybody needs me to explain where I got those 4 values? Because those are the 4 things that you're going to need.
How'd you get the lattice?
The lattice is the absolute value of A, and A is always that number out in front of the parentheses. So really you can just say if it's negative it becomes positive, if it's positive it stays positive, because the lattice is going to be the length of that segment that goes through your focus point. Alright, so let's sketch out a y-axis and an x-axis. Again, if it's not at the center, if the vertex is not at the center, you're probably going to just have to do some dashes. You may have to come back and add some more. So I'm just going to do 5 up, 5 down, 5 left, 5 right. So the process is exactly the same, except the center is just not going to be at 0, 0. So our center is left 2 and down 1. Left 2 and down 1. Then we're going to go 1 unit up. You always go p units in the direction that your parabola is going to go in. So from the vertex, -2, -1, we go up 1 unit. That point's called our what? Focus. And through the focus goes your lattice. So if the parabola is going up, then the lattice has to go left and right. And the lattice is 4 units long, so we have to divide 4 by 2, and we gotta go left 2 and right 2. And because the focus point's got to be the midpoint. So if the lattice is 4 units, you got to go to the left 2 and to the right 2, and then you can sketch in your parabola. All right. Questions about 5? We got one more, and then y'all got the rest of the block to do to start your homework. All right, let's look at something that's just way out of standard form, a parabola that's way out of standard form. Last example, example 6. So again, I said a parabola is pretty easy to identify if it's not in standard form, but if you're not careful, some of y'all might say this is an ellipse just because you see y squared and minus 2y or y squared and minus 8x, but you do have to ask yourself, do you have x and y, are they both squared? Are x and y both squared? No, they're not. Okay? So you're going to solve, so that makes this a parabola. You're going to solve for whatever variable is squared. So what's squared, x or y? Y. So you have to keep not only the y squared on the left-hand side, but you also have to keep the minus 2y. So whatever variable is squared, those variables stay on the left. Everything else moves over to the right-hand side. So I have y squared minus 2y equals 8x minus 1. Because I have a y squared and a y term, that's what tells me I have to complete the square. So if you have a y squared and a y, that means you're going to end up with a binomial squared with your y's. And to get a binomial squared, you got to have a perfect square trinomial. And to get a perfect square trinomial, you have to complete the square. So can I complete the square right now, or is there a number in front of my y squared that I need to factor out? I can do it right now. So what number can I add to y squared minus 2y? 1. And if I add 1 to the left, I have to add 1 to the right. So maybe since these are your notes, maybe you want to underline plus 1 on the left, plus 1 on the right. Just kind of so you can go back and see what you did there. And once you complete the square on the left-hand side, you've created a perfect square trinomial that will factor into a binomial squared, and that will be y minus 1 squared, and then the right-hand side simplifies to be 8x. Okay, we're not going to graph this one, but we'll collect everything that we need to graph. What's something that I need to graph?
The vertex.
The vertex. What would be the vertex? 0, 1. What else do I need to graph? The p-value. What's the p-value? 2. What else do I need to graph? The lattice. How long is the lattice? 8. And the last thing I need is direction of the parabola to the right. And then you would graph it. So you got to take this information. Hopefully you took really, really good notes. And then you have to go through the process and you have to practice it so the process will stick to your brain. Any last questions?